Today's lesson is 10.5, which deals with graphing square root functions and also focusing on some domain and range pieces. So we're going to start off more of the algebraic way to find the domain, which remember, that's all of your x values, and the range, which is all of your y values. So we know that a square root, or we can't take the square root of a negative number. So basically the stuff under the square root has to be 0 or bigger than that. So we're going to set up an inequality that represents that situation. We're going to take the stuff under that radical, 3x minus 9, and just set that greater than or equal to 0 to represent it not being negative. Then we're just going to solve that, and that's actually going to directly give us our domain. So we're going to add 9 to both sides to get 3x is greater than or equal to 9, and then divide both sides by 3 to get x is greater than or equal to 3. That's telling us the possibilities for x. So that's our domain right there. X is greater than or equal to 3. So we can always set the radicand, or the stuff under the radical, greater than or equal to 0 in order to identify the domain. Now the range, which we'll talk graphically about the range a little bit more, but see how there's not anything added or subtracted after that radical? Because of that, the range is always going to be y is greater than or equal to 0. And that's not going to change unless there's a number out here. And we'll talk about that a little bit once we get into the actual graphs and what they look like. So that's all for this type of thing. The 2 out front actually has no effect whatsoever on the domain and range, which is also kind of convenient so we don't have as much work to do. So for number 2, we're going to do the same type of thing. We're going to set the stuff under the radical, negative 2x plus 5, greater than or equal to 0. And then we're just going to solve. We're going to subtract 5 from both sides, so we get negative 2x is greater than or equal to negative 5. And then we're going to divide both sides by negative 2. Now here's a part that we do need to be really careful about. Remember, for inequalities, if we divide by a negative number, we need to flip the sign. Instead of greater than or equal to, it's going to be less than or equal to. And then negative 5 divided by negative 2 is 2.5. And again, that's directly going to be your domain. X is less than or equal to 2.5. And then, like I was talking about earlier, since there's nothing added or subtracted outside of the radical, that range is always going to be y is greater than or equal to 0. So that's algebraically how to identify the domain and range. But in this lesson, for what I'm asking you to do, for the most part, you're going to be focused on graphing and using the graph to identify that. Now, the graphs for the square roots are actually pretty quick and easy. I'm not asking for a super accurate graph. The parent function for the square root, y equals the square root of x, always starts at the origin, and it kind of looks like a sideways parabola cut in half. It's going to look like this. I don't need anything perfect or exact as far as that loop type shape. I just need that starting point in the proper location. So that starting point is identified with the numbers here. See how we have that plus 5 on the outside? That's what I was talking about earlier. That plus 5 is going to shift the graph 5 units up. Just like whenever we used to graph absolute values, if there was something added on the outside, we moved it up. And that's the same here. So we're going to take the origin point from the parent function and just move it up 5. And then we're just going to put that general shape there. Again, I don't need any additional points. Just get down that that starting point and then just do kind of that upwards curve in order to get that. Now for the domain and range, we're going to look at this in more of a visual way. Remember, for the domain is our x's, the range is our y's. We're always going to use this starting point as the guide. So that starting point has an ordered pair of 0, 5. For the purpose of all of the graphs in this Algebra 1 class, it's always going to start off as x is greater than or equal to, and we're just going to use the x coordinate. In this case, that's 0. Then we're always going to have y is greater than or equal to, and then we're going to use that y coordinate, which is 5. And that's literally all you have to do there. So again, if I give you a graph for the purpose of this class, it's always going to be x is greater than or equal to the x coordinate, and then y is greater than or equal to the y coordinate for the range. That's all we have to do. So if the number is on the outside of the radical, we're going to move it up or down that amount. If it was minus, we would move it down. So now for the next problem here, we're going to do the same type of thing, except now we have a number under the radical. Just like whenever we have the absolute values, remember when things were inside of the absolute value, it was opposite? That's the same thing here. So we're shifting this graph 2 units to the left. If it's a plus, we're moving to the left, but if it was a minus, we would move to the right. We don't have anything on the outside of the radical, so we're not moving it up or down. So we're just going to take that original point, the origin, and then move it 2 to the left, and that's going to be our new starting point. Then again, I just want that general graph shape, just like that. You don't have to put any additional points there. Now we can identify the ordered pair for that starting point, which was -2, 0. And then like I was talking about in the previous problem, it's always going to be x is greater than or equal to whatever the x coordinate was, in this case -2. And then the range is always going to be y is greater than or equal to whatever the y coordinate was, which was 0. And that's all you have to do for that. That's going to be the same type of thing for the next one here, except now we're going to do a combo of 2 motions. We're going to move either left or right and up or down. So in this case, we have a -3 on the outside. So the graph is shifted 3 units down. But then we have a +1 on the inside. So we're going to move it 1 unit to the left. Remember, if it's a plus on the inside, we're going to move to the left. So we're going to start at our starting point and move 3 down and then 1 to the left. And that's our new starting point. Then we're just going to put that general shape of the square root function, this right here. And then we're ready to identify the ordered pair, which is -1, -3. Remember, the domain is always going to be x is greater than or equal to whatever the x coordinate was, which is -1 for this problem. And then the range is y is greater than or equal to whatever the y coordinate was, which was -3. And that's all for this problem. Now for the next one, we're going to continue to go through that same type of process. So for this one here, we can see we had a +1 on the outside of the radical. That means the graph shifted 1 unit up. Now we have a -4 on the inside of the radical. So that means we're going to move 4 units to the right. Remember, on the inside, it's opposite of what you would expect. If it's a -4, we're moving right 4. So we're going to use those things to come up with our new starting point. Instead of at the origin here, we're going to go 1 unit up and then 4 units to the right, and that's going to be our new starting point. From there, we're going to draw in the general shape of that square root graph. The ordered pair for that starting point was 4, 1. So we're going to use that to identify our domain, which is x is greater than or equal to 4, coming from the x coordinate. And then the range is y is greater than or equal to 1. And that's all there is to that problem. Now we're going to move on to the next one. For this one here, we have a +3 on the outside. So the graph is shifted 3 units up. And then we have a +3 on the inside. So that's going to be 3 units left. Remember, if it's plus, it's moving to the left. So we're going to put that starting point. We're going to move up 3 and then left 3 from the origin. And then we're going to draw that general shape. The ordered pair is -3, +3. So the domain is going to be x is greater than or equal to -3, coming from the x coordinate. And the range is going to be y is greater than or equal to +3, coming from the y coordinate. Let's move on. I think I have 2 more examples in this set of notes. For this one, we have a -1 on the outside. So the graph is shifted down, or 1 unit down. And then we have a minus 1 on the inside, so we're going to do 1 unit to the right. So we're going to go 1 down, 1 to the right. That's our new starting point. Draw that general shape. The ordered pair for the starting point is 1, -1. So the domain is x is greater than or equal to 1, and the range is y is greater than or equal to -1. Then we'll have one last example. And again, these are all generally the same type of thing. We have a -3 on the outside, so it's going to be shifted 3 units down. And we have a +6 on the inside, so that's going to be 6 units to the left. If it's plus, it's moving to the left on the inside. So we're going to go down 3 and then to the left 6 and put our starting point there. Draw that general shape. The ordered pair for that starting point is -6, -3. So we're going to use those to write our domain and range. Domain is x is greater than or equal to -6. Y is greater than or equal to -3. And that is all there is to this lesson. Have a good day.